Hello everyone, this is Professor Niro Mehta from LG Institute of Technology and Engineering. In today's session, we are going to discuss about subject called Automobile System Design. In this particular video, we're going to calculate and we will have a case study for an example of stopping distance. So ultimately, now we will move on to the stopping distance example and we'll have two examples regarding to stopping distance. Then we will have example related to energy braking as well as energy absorbed by brake which is converted to heat energy and which should be absorbed with the help of artificial cooling system. So in this particular video we're going to discuss about our example for for stopping distance. So let's have our first example. So in this example, the data is given like this. A motor car has a wheelbase which is denoted by, we know that a motor car which has a wheelbase which is denoted by B, and so in this particular example, wheelbase which is given by B is equals to 2.64 centimeters, 2.64 meters, sorry, and the CG above the ground is, which is H, is equals to 0.61 meters, and the wheel, our CG is 1.112 meter away from the front end of the rear axle. So ultimately, which is symbolized by L, small l, which is 1.12 meter, which is away from the rear axle. Yeah? The car is traveling at 40 kilometer per hour. Here we can say, or our name or symbol for this is U, which is 40 kilometer per hour, which we have to convert into meter per second. So it will be like you can be represented this 40 kilometer per hour in meter per second, which is 11.11 meter per second. So and it is on a level track, so ultimately our angle which is made with a surface which is it will going to be a zero. And what we have to find is, we have to find minimum stopping distance or minimum safe stopping distance for rear wheel brake, front, front wheel brake, or and all the four wheels are brake. Here, coefficient of friction between the surface of ground and our vehicle, it is given by zero point 0.6. The first thing is to find this minimum stopping distance. An equation for that minimum stopping distance is provided by uniform acceleration theory, which is 2as is equals to v square minus u square, where we are given by u, but we don't have a. And this a can be calculated or could be find out with the help of three theory by considering. First one is when the rear wheels are braked. Clear? When the rear wheels are braked, so our equation for this rear wheel, when rear wheels are braked. So as we know that the relationship between acceleration and our length of our vehicle, depending on this particular when the rear wheels are braked, is mu into B minus L divided by B plus mu H, where mu which is given as zero point 0.6, B is equals to 2.64, which is wheelbase, minus L, which is 1.12, divided by B, which is 2.64, plus zero point 0.6 into 0.61, which is H. So H is nothing but our height of a CG above the ground. So ultimately acceleration A will be, so G, which is gravitational pull, is goes from goes here, and ultimately acceleration for this particular instant, or you can say when our rear wheels are braked, which is 2.98 meter per second square. So here we have found out our acceleration, which is also called in terms of braking, which is also called retardation. And if I want to call it as an acceleration, then I have to provide a sign which is minus sign clear in front of our value. So it is if I want to call it as an acceleration, it is minus 2.98, means it is accelerating or deaccelerating your vehicle to have stoppage. So let's put this acceleration in equation, which is 2as, which we have provided in this. So ultimately s is equals to v square minus u square upon 2a. V square minus u square upon 2a. So v, which is so here the final speed after stoppage is 0 minus 11.11, which is our u, divided by 2 into minus 2.98. Here, so ultimately the value for this will be s is equals to, our value will be finded by this particular session is to 20.55 meter. Particular section is 20.55 meters. So for this particular instant or this particular case, which is the rear wheels are braked, our stopping distance for this particular velocity and acceleration becomes 20.55 meter. Let's have another case, which is where our rear wheel or where our front wheels are braked. So after our first case, now we will deal with our second case, which is when front wheels of vehicle are braked. When the front wheels of a vehicle are braked, in this case, same, we will going to do same thing, which we will find acceleration, or you can say deacceleration either, or retardation. For that equation for that particular front wheel is mu l upon b minus mu h. Clear? You have to remember this equation for front wheel, rear wheel, and this particular video, a particular example. So mu is zero point 0.6, L is 0.61, sorry, L is 1.12 divided by 2.64, sorry, 2.64 minus 0.6 into the bracket 0.61. So ultimately this acceleration is equals to, it will be acceleration for this particular case will be 2.9 meter per second square. So now this acceleration is also called retardation. If I want to call it as an acceleration, then it should be minus 2.9 meter per second square. So ultimately this equation will be help us to find out stopping distance for this particular case. S is equals to v square minus u square upon 2a. V, which is 0, minus our u is 11.11 square divided by 2 into 2.9 meters, 2.9. So S ultimately 21.25 meters. So in this case, when we are braking our only front wheel, this will be 21.25 meters. So in first case, we have braked our rear wheel. Now we have braked our front wheel. Third case, in particularly third case, when all four wheels are braked. Wheels are braked. Clear? In that case, our acceleration will be u into g. So a is equals to u into g, sorry, mu into g. This is not u but mu. Here, mu into g, which is equals to zero point 0.6 into 9.8. So ultimately acceleration for this case is 5.88 meter per second square. So acceleration a is equals to 5.88 meter per second square, which is also called as a deceleration. We have to take it as a minus. Clear? So S will be v square minus u square upon 2a, where v is 0 because of its final velocity. After stopping, the final velocity will going to be 0, and this will be 11.11 square divided by 2 into minus 5.88. So ultimately it is 10.5 meters. I hope you understand this particular example. This particular example will going to be in your GTU and MSc for sure. Clear? This is the most important example. This portion, this particular example should be probability to be have in that example will be almost more than 50% from this particular chapter. So once again, let's get back to our example have in this particular problem, they have asked to find the minimum stopping distance for what? Minimum stopping distance for our vehicle. Clear? Which is given by our base, which is 2.64 meter. Clear? Height is 0.61 meter. Clear? Length is 1.12, sorry, length distance from the CG, distance of a CG from our rear wheel is 1.12, which has velocity, initial velocity, mu is equals to 11.11 meter per second. Clear? And mu is zero point 0.6, which is coefficient of friction. For first case, our equation for acceleration, all we have to find is acceleration. To put that acceleration into 2as, for the first case, our acceleration was minus 2.98 meter per second square, and the stopping distance is 20.55 meters. For second case, when the front wheels are braked, equation will going to be different, and our value will be different also, minus 2.9 meter per second square, and your stopping distance is 21.25 meters. And ultimately, when all four wheels are braked, okay, acceleration is minus 5.88 meter per second square, and stopping distance is 10.5. So from this particular example, we have learned that how to find the stopping distance for all the cases which we are provided here. Yeah? I hope you understand this example very well. Let's move on to next example, which is the same, almost kind of a same example. Clear? Where our base is 2.25 meters. Clear? CG above the ground, which is H, is equals to 0.55 meters, and L, which is in front of length in front of or distance in front of axle, is zero point 0.1 meter. Sorry, 1 meter, not 0.1 meter, but 1 meter. If the car is traveling at 45 kilometer per hour, so u is 45 kilometer per hour. If I want to convert into meter per second, all the values should be in SI units. All the units should be in SI units. So it is 12.5 meter per second ultimately. Clear? So what we have to find is determine the minimum distance which car may be stopped. So first we have to find when rear wheels are braked. Clear? At the same time, second we have to find when front wheels are braked, and ultimately then we have to find coefficient of friction, and the coefficient of friction which is provided here is 0.6. So all we have to find is the same stopping distance for all three cases.